Understanding Machine Learning Predictions with SHAP.
Welcome to our channel. Today, we're diving into the world of machine learning interpretability, focusing on a powerful tool known as SHAP, which stands for Shapley Additive Explanations. If you've ever wondered how machine learning models make their predictions, or if you've faced the challenge of interpreting complex models, this video is for you. We'll explore how SHAP can help us understand model predictions through a simple case study.
First, let's break down what SHAP is all about. SHAP values are derived from cooperative game theory, specifically the concept of Shapley values. In this context, each feature of a machine learning model is treated like a player in a game, contributing to the final outcome.
To illustrate this, let's consider a hypothetical scenario where we have a decision tree model predicting whether a person will buy a product based on three features: age, income, and previous purchases. Imagine we have an individual with the following attributes.
Age 30,
Income $50,000.
previous purchases 5.
The model predicts that this individual will buy the product. Prediction = 1. But how do we know why this prediction was made? This is where SHAP comes into play.
Using SHAP values, we can visualize how each feature contributed to this prediction. Let's say we generate a bar chart that shows the contributions of each feature. Age +0, 2. Income +0, 1. Previous purchases -0.1.
In this visualization, the positive contribution from age indicates that being 30 years old increases the likelihood of purchasing the product.
Conversely, the negative contribution from previous purchases suggests that having made 5 prior purchases actually decreased the likelihood of buying this particular product. This breakdown allows us to see not just what the prediction was, but why it was made. In medical diagnostics, doctors often rely on AI models to predict patient outcomes. For instance, if an AI suggests treatment options based on patient data, SHAP can help medical professionals understand which factors, like age or previous health conditions, are most influential in that recommendation. This transparency can lead to better patient trust and adherence to treatment plans. In credit scoring systems, lenders must justify their decisions to applicants. If an applicant is denied credit, SHAP can explain whether factors like income or previous debts influence that decision negatively. This not only helps applicants understand their financial standing, but also ensures fairness in lending practices.
Businesses often use predictive models to determine customer behavior. For example, if an AI model predicts that a customer is likely to purchase a new gadget based on their browsing history and past purchases, SHAP can clarify which aspects, like previous purchases or demographic information, played the most significant role in that prediction.
It's crucial to note that while certain features may seem important in predicting outcomes, like chlorides or acidity in wine quality predictions, they may not always contribute positively when evaluated individually. This highlights the importance of using SHAP values to assess model accuracy with and without specific features before making decisions about their inclusion. In conclusion, using SHAP allows us to break down complex model predictions into understandable components. By visualizing how each feature contributes to a decision made by our machine learning model, we enhance transparency and build trust in AI systems. As machine learning continues to permeate various sectors, from healthcare and finance to marketing, the ability to explain model predictions becomes increasingly vital. Tools like SHAP not only help us understand these predictions, but also empower stakeholders to make informed decisions based on AI outputs.
Thank you for joining us today. If you found this video helpful and insightful, please give it a thumbs up and subscribe for more content on machine learning and data science. Let us know in the comments if you have any questions or topics you'd like us to cover next.